How you doing, buddy?
Hello, Mark. How are you? I'm doing good. Yourself?
I'm pretty good. I've been like prepping like crazy for what we're gonna do this morning. First I was like, oh, this might be a little challenging, and now I'm like, okay, I think we got a shot of making it through. So,
Excellent.
how was your weekend? Was everything good?
It was good, yeah. Bit of time to relax, kick back, recharge the batteries, as it were.
I'm always terrified to ask that question. Right? Tragedy struck, Mark. Why did you ask? I'm like doing therapy for 2 hours on the show instead of writing code, you know?
Nah, I'm good, man.
All right. I'm glad to hear that. Pretty good over here, too. I don't think any significant tragedy has struck now that I think about it,
We're all
which
still alive.
we're all still alive.
Another good day.
Right up there, I'm going to be speaking in Las Vegas, March, I think 6th. I'm going to be there on a Thursday. I'm going to be doing Science of Great UI Part 1 and 2. So you can use that speaker code that shows up there to get about $400 off if you want to come check that out in Vegas. I'll see you there. So design is like one of my passions, researching it, understanding it. I spent about 10, 12, 14 years researching it, off and on, and then in the last like 6 years, a lot more focus on the cognitive science aspects behind that could justify guidelines in user design. And so I'll be going through some of those there, and sometimes on the show we talk about those as well.
Yeah,
Yeah, it's not bad. Let's switch over to this view right here. Maybe not. Let's do that view right there instead. I want to show right here. This is where we've got the source code. Checking it in here. We are going to work on a WPF application today. That WPF application, I've got the starts of it out there, and the start of it out there in this check-in. And we are going to, this is going to be an application that I'm building for one person to use. That person is Richard Campbell. You probably know him from .NET Rocks and speaking at conferences and other things. He is, I think, widely considered, at least within this house where I live, he is considered the smartest man on this planet. Absolutely.
He's an awesome guy.
Yeah, everyone else I know, that's the smartest folks out there. We're all about here. And I say we because I'm going to put myself in that group. I may be down here a little bit, but we're all here. And Richard Campbell is like noticeably godlike up in this area. But the application we're creating will be used by Richard Campbell. Richard Campbell is going to be dungeon mastering for this new Twitch live stream that we're creating. At least that's all the intention, right? That's the letter of agreement that everybody's signed, essentially. And
That's how it'll be when you say go. How it falls out after that.
Right. Right. Well, you never know, but it could be that it's never used. But we're building this, and it's going to talk to some of the stuff that we've already built, the overlay that for the live streaming, which I think is live right now, and we can test that by going in the chat room and typing in test scroll. Let's see what happens. Nothing. Am I not running? That's probably why. I haven't started it yet, so let's start it.
That would help.
Yeah. Let's see what's going on here. Build errors. Let's see. It looks like I needed to delete this right here. Let's delete that bit of code right there. And start now. See what happens. And Mr.
Announcing his presence in the chat room.
You caught him just like I did, same time. Good job. And there we go. The mark just worked. Looks like this is our error that says, whoops, we've got to kill all instances of Chrome. So I'm going to do that. We're going to restart one more time. You sent in Mark a second time. Okay, I was like, wait, what? Did it figured that out or no?
The first was when it wasn't running. The second was a second time, yeah.
Yeah, I see that. Okay, no worries. I was just like a little bit like, what? All right, one more time. We're going to start that up. See if this works here. We'll see Mr. Announcer Bot come in again. And in the house, there we go. And now we have a couple things happening here. There we go. Whoa, look at that. It already tested it for me beforehand. So there, the scroll comes in right there.
That's looking nice.
It's not bad. Yeah, we've got the graphics there. So check this out. If I type in test 1 like this, it's going to switch to player number 2, which is Ava right there. If I type in test 2, it's going to switch to player number 3, which is me. And then if I type in test page 2, it'll know I'm not switching characters, so it'll just roll up the scroll, unroll it, and now I see the skills.
Cool.
I need to add a page 3 for equipment, but this is essentially the look. This look for both page 2, here, let's go back to page 1. Page 2 and page 1, you're seeing these over the stream here. These are they're live graphics over the stream. It's for Dungeons & Dragons show. And one of the things that we've done is and I say we, and everybody's like, who's we on this, Mark? Who's the we exactly?
That's pretty much you.
Yeah, it's pretty much just me, I think.
Yeah.
But I say we because it's a collaborative effort. The show is everybody together, that sort of thing. So, by the way, I'm noticing what looks like a really bad bug over in the standalone version of the thing we're supposed to be testing.
Oh, okay.
Take a look at that. It's
less awesome than on the stream.
It's like never-ending magic. I have no idea what that is. I'm not sure how
It's like it jammed partway through the unroll.
Yeah.
And it didn't get around to putting any stats in either.
Yeah, and I just want to refresh this over here. I'm not sure how we got there. Hopefully, it smells like a state bug. I just refreshed it. Let's do a test. Let's see what happens if I do test back to 1 again. So now if I switch to 1, it should know, oh, wait, we're on a different player. So it should close up on the 1. Look at this. What's going on here? Do we have any messages? Oh, we do. Can it read property render of undefined? Okay. Well, that looks kind of bad.
Draw character stats, line 333.
Active page, start page, this page, selected stat page index.
There's an active page right there.
What?
How
many? It's the index is, I think, the problem. The index is too high, is what it feels like. So it looks like it's starting to unroll it, and it gets the error. That's what I think is the problem here. Let me try this, though. Let's empty cache and hard reload. See if that makes us. Would that help us? Maybe. The cache may persist across the death of Chrome if this suddenly works now. So let's try this now. Test 2. Nope. Still same problem. I have an idea, though. You know what my idea is? I think I know how to fix this. I'm going to refresh. And my idea is this. This didn't get a start with the test scroll, but you gave one here. Test scroll initializes and adds the pieces. So now if we come in and say test 1, we should see it swap. There you go. Now it's working. So it's just
it's a presumption of existing state, but of course if it didn't receive the first command, it didn't set itself up. That's
what it is. Okay, so that's what we've got. All right, so it's so now we can swap between all of those, right? Intelligently.
Bug-free, nothing to see here. Everything good.
Well, yeah, we'll make sure it's bug-free by the end.
Code is flawless.
Yeah.
Until proven otherwise.
It's not bad. Okay, so there's that. So this is like a graphic that's there all the time. One of the cool things that we've done on this graphic is we've made it so that this is it follows the principles of the science of great design. So as an example, important information is in higher contrast. We're using color with intent. So anytime I've got a modifier that is going to be positive, the modifier is going to be in blue. And
makes it easy to see as a glance. That's good.
Yeah, and if let's switch to another character here. These are all just random kind of numbers, but there we go. Now we've got some modifiers that are negative. They're going to show up in red. And a modifier that's neither negative nor positive is going to show up in this kind of very, very light color, indicating there's no modifier here. But you can look for it and see it. The other thing that's very cool about this is we're taking essentially full pages of character sheet data and compressing them into the smallest possible space. And the other thing we're doing with these that's very cool is we are staying consistent with those character sheet, the character sheet graphic
sort of symbology.
Yeah, symbology, the graphic convention there, exactly.
Geometry, as it were.
Yeah. So we're doing that as well. So that's what's going on. And what I mean by that is if you open up a standard Dungeons & Dragons character sheet, your armor class is going to be inside a shield. And you're going to see your strength pieces typically stacked up in this order with ellipses around them, that sort of thing.
So it should be immediately familiar to anyone who's done this before on paper or any other mechanism that's, again, tried to follow those standards.
Yes, exactly. The directions in terms of where we're going, bring this up over here. And this is the last page I'm going to add. I haven't added this yet, but it's going to be basically an equipment page that'll have gold pieces, what your speed is, because your speed can be changed by how much weight you're holding, right? And so we're going to have all our items and the weight, and you'll see the total weight that you're lifting plus your own personal weight in case somebody needs to carry you, and all your equipment. We'll be able to quickly answer that question, is that possible? So this is the background here, and this will be a number of these pages depending on how many items you've got that you're carrying with you. And if there's more than one item, like if you have 2 rings of protection, we'll put the quantity at the very beginning. So we won't have a separate column for quantity. And all of this is going to live update based on how Richard interacts with, how the Dungeon Master interacts with this page. So that's kind of that right there. There's this. We can drag this off. So now what I want to do is I want to kind of go back to SignalR. And actually, let's not review that yet. Let's go take a look at my app. Now, to get here, I'm gonna stop debugging so I can start making changes over here. And that may make things, keep an eye on the chat room, Rory, for me, because we are, slightly disconnected from them, I think, in this moment. So I want to show you what I've got over here. This over here is the Dungeon Master's application that's I'm building in WPF. This is the application that the Dungeon Master was going to use that's going to manage the game and also live change what's going on over in the graphics that you see in the overlay there. I'm going to, by the way, I'm going to refresh the cache of the current page, so we're going to get rid of that scroll there. So there, it's gone, and that's just impacting the stream as we're sending it out there. And so this is the app that they're going to use. The design of the app looks like this. Let me move the XAML down a bit, bring this over here, zoom in a bit. So it goes like this. These are the players. So these are the players. So the Dungeon Master will be able to select a player when it's their turn. And I intend to probably have some really giant, big, easy way to do it, because this is happening all the time. And these small little tabs are small targets, and I need them bigger. We'll fix that later. On each of these pages, it's going to have 3 of these kind of scroll views. And so I'll be able to click this as a Dungeon Master. Click, for example, dexterity for a dexterity saving throw, right?
Yep.
And what I want to have happen on the viewing side of this is I want that page, that character to be displayed. So do what the slam or the scroll and scroll, whatever's needed to get there, and then highlight the thing that the Dungeon Master has selected. So the Dungeon Master is going to be saying, well, you need to make a dexterity saving throw, and the Dungeon Master is going to click that. But what's going to happen is the viewers are going to see these cool graphic effects along with the highlighting, so their eyes will be directed to the bonus modifier that affects the roll.
So it's very like, to take a sort of sports metaphor, you've got somebody calling the plays from the commentary box, and as they call them, the guy on the camera is switching to watch specifically in close-up what's going on.
Right.
So as Richard decides to have some event happen and you need to do this and that, the very fact that he's focused and clicked on it with the mouse will automatically shift attention of anybody watching the stream to that, or at least highlight it in addition.
Yes.
That's very nice.
I also want it to change the views. So we're going to have, the way this is going to work is we're going to have all of the players stacked up like this, right?
Sure.
When it's Karen's turn, she'll be up on top like this. When it's my turn, I'll be on top. These are switching different scenes. So in addition to showing the right scroll page, we need to switch scenes so that that player is on top of all the other players, right? So we're going to be switching OBS scenes. It's essentially we're creating an automated bot to control all the live graphics and scene switching while the Dungeon Master just plays the game using this app.
Actually going to switch scenes, because I've noticed that when we've done that here for this stream,
yes,
it has automatically cleared out things that are not present. So for example, if you had a scroll on screen on the right page,
yes,
and you click a different page, or Richard clicks a different page, is that going to need to slam the scroll back onto the screen? Because
no,
it will have been removed.
No, watch this. I just did test scroll. Let me see if I can do test awesome. Is awesome going to work, or probably not? Awesome's not going to work. But there's the test scroll. I'm going to manually change to awesome. Okay, hold on a second. Here it comes. Awesome. Notice the scroll didn't change. The reason it didn't is because if the other scene also has the overlay bot on it, the same overlay, it will not reload it. So even a particle system, even if it's opening, right? If we come in and we come back over here in the chat room, I'm going to change to good design right after I type in test 1 to switch to the Ava character. So I'm going to hit enter in the chat room, and then I'm going to switch to good design. And as it unrolls, you should see the scene change occur while the overlay is running. Good design.
Yeah.
See that?
That's good.
So
the only reason things vanish in our other situations is because the overlay bot is not in both scenes.
Right, exactly. So for example, if I switch to this scene, overlay bot is gone. Right, I'm just manually doing that. Switching back over here. Wait, hold on. What's going on here? Oh, I think I have overlay bot missing. Wait. Oh no, back. Hold on. I'll bring it up. I'll fix it. It's there. There we go. All right. Well, I was playing around with some stuff and I turned something off on that particular view. But anyway, when I switch back, we can now bring it back by typing in test scroll inside of there.
We're going to have all this interactivity, all this stuff triggered by Richard, but you're also going to have different scenes set up for different events that maybe different people who are the focus of the current form of play, that kind of stuff, and it's all just going to meld together perfectly into a stream of awesome.
And I feel like we can end the show right there, right? We don't have to write any code. We just spec'd it out, and it was so awesome.
Yeah,
the code should write itself.
Play it straight away. That's
Wait, what year?
Convince anyone.
What year is this? Oh, dang, we're still in 2019. That's not happening yet. All right, so we're going to have to write our code. Who's saying hi out there? Soldier24.
Soldier24.
Hello, Soldier. Hello. Greetings and welcome. Okay. So that's the overview of kind of what the big picture is, where we're going. For now, what I want to do is I want to build this, make it so that I'm going to start by making it so when we click on one of these images, it changes the page. And when we click the tab, it changes the page. Yep. Maybe let's start with just the tab. Let's do that because we got to do some SignalR. We said we're going to do it. In that case, it's time for a SignalR review. And guess who barely knows SignalR, kids?
That would be us.
Yeah, that's us. That's pretty much us. So here's what I did this morning. I went through and I said, hey.
You prepared.
Well, I don't know. I'm not going to call this prepared, but I went through and I said, let me figure this out. Because the last time I was trying to figure this out, there were like 4 or 5 connecting pieces. And I was like, trying to get them all together. We managed to get it to work. I feel like it was entirely due to intervention from the programming gods. And not so much with us being geniuses, even though at the end we said, we are the geniuses. And we chanted.
Seat of our pants sliding under the
underneath this
Indiana Jones.
Yes, we just got underneath that, and the whole thing worked.
It was awesome. You want to go watch that episode, guys? It was great.
And so, so what I did is I said, okay, let's take a look at this. What's going on here? We've got 2 hubs that we've built so far. One is called the CodeRushed hub, and one is called the Mr. Announcer Bot hub. Okay.
Sure.
And the CodeRushed hub has commands called chat, whisper, add coins, need to get coins. Those are the 4 methods that CodeRushed hub.
Just to jump in quickly, Mark, a hub, if I remember correctly, am I right in saying that a hub is effectively a server-side point of communication through which other parts communicate.
Yeah, I would say that's
Yeah.
exactly it.
So there's a message goes from one thing
to another
the hub and then
yes.
back out the other side to something else.
Yes, and so our CodeRushed hub is currently being used by our TypeScript application to chat, to invoke chat, so we can chat from our TypeScript application by going out to the CodeRushed hub, because CodeRushed hub knows how to talk to Twitch. And so it can then say chat or whisper. We can also add coins, and so in the past we've created games where drones fly around and collect coins, and so we wanted to add coins, and then that goes out to our CodeRushed hub, which in turn goes out to our Mr. AnnouncerBot hub and calls add coins to it, so that we can add coins to where we're tracking for each player.
That's right. In this case, of course, the two hubs talk to each other.
Yes.
They kind of pass information between each other before then talking to different clients.
And we also added a need to get coins so that the TypeScript application can say, hey, you just created a new drone. I don't know how many coins this player has in total. So, get me what their total is. And so we call need to get coins. Now, SignalR doesn't give me the ability to return a value on any of these calls. I can't say need to get coins and wait and until it comes back synchronously with here's your coins. That does not happen. Okay. So what we had to do is we had to create another function in here, another method called user has coins, and that sends data to our TypeScript application. And our TypeScript application is listening for this, and inside of our C# app, we go get we first listen for this thing. We say, oh, somebody wants to know what the coins are. Who are they? Then we say, okay, this user, we find out who they are. We pass that user ID, has this many coins, and we call this. And so the whole thing is happening totally asynchronously, and that's what we've built so far.
So it's less like a telephone service in which you could just have a continuous conversation back and forth. It's more like the postal service where you send a letter saying, I need to know how many coins there are. And then the person in charge of the coin sends you another message back the other way later on going, this person has so many coins.
Yeah.
And it all gets through like that.
I kind of envision it, when you said it's more like, the first thing that came to my mind is it's more like paper airplanes. It's more like writing down, here's what I need, and throwing it right across the room.
Very little wind, hopefully.
Right? Like if you're taking a test and you want to know, the answer to a question, you want to do it so it doesn't attract attention. You write it on a paper airplane and you send it across, right? And it lands.
Yeah.
And you wait for the paper airplane to come back. Right?
Okay.
Like the answers I always got was cheating is illegal. You're not being clever. Sign the teacher. And I was like, oh, the teacher would send me the paper airplanes back. All right, enough of my life and my attempts at, greatness. Here we go. Let's see, hub instantiation. So these were done in the constructors over here. Those were how those were built. But we don't need to create a new hub. We don't. But what we need to do is we need to create a way to send data is what we need to do. The connections I've got right here, I was noting how we were initializing the connections. We're going to need something like this right here, where we're going to need to go in and hook up to the Mr. AnnouncerBot hub. Mr. AnnouncerBot hub currently has user has coins. That's how we send data. We need to do something else, and that's going to be to let's go work on that right now. So that is our Mr. AnnouncerBot hub, and that is in our hubs folder right here. And Mr. AnnouncerBot hubs is implementing iAnnouncerBot commands. And wait. User has coins. Wait. It's not implementing that. It's got user has coins. Hold on a second. User has coins. So this is what we're modifying here, the overlay command. So these are commands we can send to the overlay. So what we want is to create something like player changed, I think. Yeah. And I'm going to pass in the player ID, I think, like that. Maybe use a uppercase D to be consistent with up above. And then I think I'm also going to pass in a string, which is going to be the player data, which for now, for today's show, is going to be nothing. But what I'm going to do is, what I want to do is I want to pass in a JSON formatted serialization of a C# class that we create. That we're gonna pass in there. That's gonna have the player data. That's gonna fill in all the numbers and everything, and have that. So the players change. There's the data that comes in. So that's one of the things we need to do. We also need to have a page changed piece in here as well. Page changed, and I think that's going to be. I'm thinking it's going to be a player ID and a page ID. Both of those, I think, I'm going to send. I think, just in case, just to make sure that we get it all, that's all correct. I could combine these two. I guess arguably I could come in here, player, page, changed. And I could just have one, that might simplify things, where I just have one call, and when that call occurs, I send everything over.
Yeah, more of a state changed almost.
Yeah, and my sense is because the only thing I'm thinking about is, that player data could be big, and what I do is it make more sense, because when I'm just changing pages, do I need to do that?
I'm trying to remember how this works from the server perspective, whether we get to sort of remember state from the previous call. Because if we do, then you could potentially send string empty for a lot of the player data after successive changes, because you don't necessarily need to send it again.
Oh, yeah.
Still give you the same structural side.
We can definitely remember state in our WPF app, right? And we don't, because we don't care about really the state on the other side. Yeah, you know what? I do want to send these two for sure. Because what if it didn't get it? What if for some reason it didn't get that and now we want to change it? I don't want to just change it without that. I want to make sure that we're always doing that.
The other thing you've got is that if the messages arrive in a different order to that which you send them, then you might change the player, page 2 of the existing player, before you then change the player.
Yeah.
And that might look a little inconsistent.
I'm thinking that too. Now I want to do focus, what are we going to call this? Focus item, maybe, is going to be another one. And so what we're going to do here for focus item, I guess again, I'll say player ID, page ID, and then the string is going to be the player, the item ID is the string.
When you're talking
there.
about items here, you're referring to things like dexterity and other statistics that are on the page.
Yes, exactly. Because I want to be able to, this is when they click, when the Dungeon Master clicks in the strength column, the strength entry, I want this whole thing glowing right here. So visually, I want to be on that page, that sort of thing. So focus item is, I think, going to be there. So those are the two pieces that we need to do right there. So what we can do is just as a model, is we can just do a search for user as coins and see where that is inside of here. And we can take a look at that, see where we need to work with that. So I announcer bot commands. Why is this here? Need to add coins, need to get coins. I feel like this is...
I think that's the one message that was in both hubs. Was that right?
Yeah, but I don't...
It was going to be sent from point A to point B and then back to point C.
Oh, maybe you're right. So we don't need this here. I'm going to argue that we don't need to do our thing here. I think you're right that we did need that. It was an ABC thing that was going on.
2 players involved in this
Yeah.
communication.
Yes, I believe that's absolutely correct. I'm going to do this right here.
Actually, is that true?
I don't know.
Got the WPF application for Richard. You've got the...
Oh, is it true that we only need one? Yes, I think it's absolutely...
I think we still need A, B, and C.
I don't think so. I think it's A... Well, let's try it, and we'll see what happens. Okay?
Because I think we have to consider the server side as distinct from the TypeScript. And that makes 2 things plus Richard.
All right, we'll give it a shot and see what happens. You can save us if we end up colliding into the wall. All right, so so we have this one right here. We've written down A to B to C just in case. And we have, wait. This is iAnnouncer bot. Get coins. We have this one. This is so these are all of our commands that are going down to the overlay. Let me just put this up here. Commands we send down to the overlay. Like that. And let's keep going here. This is inside of our Mr. Announcer Bot Hub. Here's the A to B to C piece right here that sends it over to there. You might be right about that.
Yeah, I'm actually second guessing myself again now. I think maybe you were right the first time.
Okay, we'll see what happens. We'll see if we can do it or not. Let's.
Definitely 3 points, but I think we can still get away with 1 hub.
All right.
That's what it is, isn't it?
Now we're into TypeScript right here. And so this is where we want to definitely add a connection on right here. So we want to come in here and we want to say, right here, we want to do player page changed. If that's the case, we want to do player page changed like that. Come down here, function, player page changed. Let's go get these pieces and pop them in. And let's swap them around here. That's going to be a number. Page ID is going to be a number. And player data is going to be a string like that. Okay. And get rid of those red squiggly underlines for me, Visual Studio. Thank you. Okay. So there's player page change. So we've got that piece. And then we want to do connection dot on.
Focus item, was it?
Yeah, I want to see if I can get, I want to do this. Whoops, that. And I want to see if I can do, there we go. That's what I want to do. Focus item. Is that what it is? Yep, focus item, just like that. By the way, notice how when I selected that and I changed it to this, it gave me the lowercase on the F there automatically.
It's very nice.
Because it's awesome and it likes me. All right. All right. So let's see. We're getting here. We're going to get these pieces. So it's essentially the same pieces we saw before, like this.
Yeah.
I'm typing in TN for type of number. Like this, TN like that. It's going to expand like that. And here I'll type in TS, type of string. All right. So we've done that.
So essentially we've registered to receive or handle these extra events almost that the hub will be capable of sending.
Yes, yes, yes. And so we've got these 2 pieces here and announcer bot. The last one here is this invocation that happens. This is how we invoke it. And so we call invoke async. Now this hub connection, so this is where the A to B to C thing is happening, I think. And I think you're right. We are going to I'm second guessing myself on this. This hub connection here connects to the Mr. Announcer Bot Hub, which is got this. User has coins. This is coming from the iAnnouncerBot commands, which is this. I think we need to do the A to B to C, is what I think we need to do. Unless, let's try to bypass it. And if we bypass it, let's go with that theory that we bypass it. In other words, our connection is going to be a different connection string. Okay? So let's copy that. Let's actually copy all of this right here. And let's go into here. Inside of here, let's create a function called connect, I think. Connect to hub. Like that. It's nice to be back in C# after being in TypeScript for so long. There we go. Let's declare it as a field. There's my hub connection. And so what do we got here? Plus equals, we'll get a, what are we doing in hub closed over there? Huh. Absolutely nothing.
Yeah.
Let's do this. Oh, it needs to return a task. All right, let's comment that out for now. And we'll comment this out and work with that later. Okay. So we are going to similarly comment that out. And now we need to kind of work through these things here. Add coins need. So this is our hub connection here. we needed to hook the other one up because we needed to kind of get we need to listen to these things is what we needed to do. And so what I think we needed, we're not going to have any hub connection on pieces on here that I know of yet. There's nothing yet that we're going to be sending this way. But I think that this needs to change to our overlay hub is what I think we called it. Is what I think. Like that. Let's double check that. Hubs. CodeRushed hub. Oops. So there's our CodeRushed hub. So now with the CodeRushed hub, we want to make a call on something. It's going to be in the same format as this right here. It's going to be that. So to call, use something like this. Like that. Hub connection, invoke async user as coins, or whatever that's going to be, whatever we're going to call. In fact, let's just add, let's kind of do this right now. Let's create a new function. And, whoops, sorry, new function. And it's going to be send player data changed, maybe? Player data changed, I think. And it's going to have a player ID, a page ID, I think. Or no, it's not. What is it going to do? I'm going to say yes for now. And it's going to have player data. Like that. And then we're going to come in here, and I think that was the same name as the function player data changed. Still with me, Rory? Player page changed.
Sorry, I just accidentally muted you. But no, that is absolutely correct. That's what that mimics on the other side. And we're going to have those three parameters passed in.
And so we're going to pass in these parameters like that. Player data. Okay, so that's how we do that. And then if we want to do the other one, let's do this. Let's change player page changed. Let's call this, give it the same name. And come in here, take that, select that whole thing, duplicate that line. And now we're going to call this item changed, right? Or focus item, right?
Yep.
Focus item.
Focus item.
Oops. Okay. Like that. All right. And the difference is this is going to be the item ID.
That's the one.
ID like that. And if that's, let's make sure I'm correct on that. So that's how we send messages out.
That's right. We're strongly typing on the XAML, that is to say the Richard's application side of things, how we will then invoke, i.e. through the wire, or over the wire.
Yeah.
Just to make it nice and easy to use.
So focus
we could
item.
have just called invoke directly from wherever, but that just makes it a little harder.
I'm just going to copy both of these from iOverlay commands, come back over, paste them down so we can visually see them side by side right here. So we've got focus item has got a player ID, page ID, and item ID. That's good. Player page changed. It takes player ID, page ID, and player data. Good. Okay.
All good.
Not bad. Next thing we need to do is call these at the right time. Tab control selection changed is here. So I think we can come in and say player page changed. And we're going to say player ID, which is going to be, let's go give the tab. I don't think we have a name for this tab control yet. Let's go look at the designer.
Yeah, this is going to be interesting because it depends how you're storing the data locally, doesn't it? As to how we can get that information in order to then transmit the correct values.
Let's see here. I think I got a template X in to give it a name, and so we're going to call this. I'm going to call it tab players, like this. And let's come back over here, and then we're going to say this, and the player ID is, I'm going to just say tab players dot, what do we got? Something with the word index in it, I bet. Selected index. And then I'm going to pass in 0 and null for the, or maybe stir.empty instead, maybe, like that. Okay?
Yep.
So there's player page change, right? So that might be enough on this side. Now back over.
Have we got a page that is indexed on 0, or are you looking to have a sort of a null state? Because I thought we had page 1 and 2, not 0 and 1.
Yeah, it's indexed on 0. It will be by the time it gets in. We're about to write that code anyway.
Fair
So let's go look at that. That's over in, where is it? I think it's connection.ts right here. Yeah, here's where these come in, right? And so what I think I want to do is say, hey, if active game is an instance of the dragon game, like that, then I think we're able to do like active game dot, isn't there character stats, scroll in there?
Nice.
Good.
Yep.
And then I want to say, actually, I don't want to do the focus stuff yet. Well, we can write it. It's not going to hurt to write, get it here for now. Player ID, page ID. We can put some console log lines out there inside of this. So we're going to do that, and then we're going to go do the same thing here. Change it to player page changed. And player data. Like that. And let's go in. Let's declare that. Let's declare this. Let's go inside both of these. Let's get us a console log. Player played changed. Let's change this to an interpolated string. Whoops. That goes there. All right, so there we go. Player changed, player ID, page ID, and player data. Like that. Okay, so there's
good. Yep.
that.
Should make life nice and obvious.
This one is just needs item ID at the end here.
Yep. And I changed the event name on the left.
Thank you. Yes, of course. Focus item. All right. So now, we're not going to really do anything yet. I just want to see.
No,
this is just
very obvious that the communication has worked.
Yeah, or that it's failed. Right.
True.
Either way,
Yeah.
I'll take that. Okay. So I think that's it. I think I'm ready to run. Is what I think I'm ready to do. Let's make sure we've just double checked.
Are we definitely going to be starting both applications at the same time? I know sometimes
Yes.
the solution has to be configured to.
Yes, I have done that already. I have
Cool.
pre-configured to start the app.
All of this prep, it's almost as if massive organization.
Yeah, I like that. It's
I'm
almost as
impressed.
a. Well, Will Bennett saying name of. Thanks, Will Bennett. Here, I think. Is that what you're talking about? Can I do name of the current method?
That does ring a bell.
All right, let's look at that.
Does that work in TypeScript?
Can you research that for me, Rory? See if you can find that for me. Name of JavaScript, TypeScript. My money's on Will Bennett
Name
to
of
find
operator.
that. Oh, he's saying
Yeah.
it's in C#, though. He's saying C#. Did I fail to do that in C#?
Name of operator.
Where the heck were we? We were over here.
So I found a link here.
Oh,
It says,
interesting. He's suggesting using it here, I think. Right here and here, because we're doing the same
be.
thing in both.
Well, it turns out it does exist, not directly in the language, but actually you can make your own in like a single
Oh,
line.
got it. Okay. So I am not going to change these to using name of. And the reason why is because these are not the same as this. This is the thing that's declared out elsewhere that I don't even have a reference to. It's declared, so it's essentially a contract by name. of the function is essentially what we've got here. That's over in here. It's
Interestingly, it would be worth doing if the thing you were referencing was in the same project, because then various static analysis tools would be able to rename one thing and it would affect the same thing. But we won't have that connection between the two. There's no inherent link other than by convention.
You know what's interesting here is that I connected to the CodeRushed hub, and I think I'm connecting to the wrong one, because the CodeRushed hub has command chat whisper add coins need to get coins. Oh wait. I don't know, but it implements I overlay commands, right? Overlay commands gives me these. If I understand it correctly, I think I'm okay. So let's see. I'm here like this. No, thank you. Let's bring up the console. And we're here. Here's my app coming up right here. Come on, app. There it is right there. So there's the app. Now, hopefully, if I click here, we're... Okay, stop, Rory.
I was figuring you needed an initialization.
No, all right, fine. But it doesn't matter because I'm just looking for the console. Let's click on this, and I'm not seeing anything. All right, so let's set some breakpoints and see what's going on. Okay, so we need to go to this.
To start another XAML, yeah.
Right here.
So we are definitely connecting to the CodeRushed hub. That's the first thing to be aware of.
Yeah.
And we're going to invoke on that either the player page changed or the focus item.
Yeah. So let's do this and that, and let's see if we get any breakpoints on there. Oh, we are getting to a breakpoint here. So we're doing that. There's nothing really we can do, I think, in terms of stepping beyond that piece right there. So that player page change has been invoked on the hub connection. The hub connection is the CodeRushed hub. Then the next thing we need a breakpoint is inside connections.ts. I guess we need a breakpoint here and here. Are we even going to get here? Right? Execute command user has coins. Right? Player page changed. These are feeling like we should come out here and get here, but we are not. Now I am not happy.
Sad panda!
I'm a sad panda.
Yeah.
That's what I am. And I don't know why. I'm like, wait a second. We didn't get to connect to SignalR. We can say, well, wait, hold on a second. User has coins, execute command. We can do like, let's do this. Let's set a breakpoint over at, hold on. Where's execute command? It's over here. Let's set a breakpoint there. And a command that we can do is, I think, like seed, for example. It does set a breakpoint here. Why are we getting to this and not the other one? Is the question. Execute command.
Right, so that just proves that the chat room's connective mechanism is working and the WPF app is not.
Will Bennett says the commands aren't implemented by CodeRushed Hub. CodeRushed Hub also doesn't implement execute, right? In other words, execute, the way I'm seeing it is this piece says what things basically defines the, it defines essentially the contract of what we can send. These are the things that we implement when we want to make a call on a particular when we want to, invoke on it though. Is that it? Is that where it is? It's the invoke. Let's go look at invoke over in, over here, view code. So hub connection, so we're calling the hub connection invoke async. Yeah, I guess I was thinking is whatever was passed in there, we didn't have to necessarily implement it, but maybe we do. So,
okay.
Incoming raid. Looks like C# Fritz is bringing everybody in. Wow. Excellent. Just what we need.
Hello, everybody.
Just what we need. Rory, give everyone a kind of an update
rundown
of where we are. And I'm going to keep... Good.
we have built many things on this channel. However, at the moment we are building the tools necessary to run a new stream. The new stream would be a live Dungeons and Dragons game wherein there will be a dungeon master and several players. So we have character sheets, we have the rendering of those character sheets, we have the rendering of the changing between the different pages of a sheet, so the scroll will collapse, it expands. This is all working, it is all absolutely awesome. What we're building today is an additional WPF app for the dungeon master, which will have all the pages on display at the same time, so that he can then decide, okay, such and such an event has happened within the scope of the game, and you need to make a saving throw against strength, perhaps, something like that. As a result, he will click the strength indicator for the relevant player, and as a result, what he'll effectively cause from a remote location, because this is not all happening in the same location, he will send a SignalR message to the portion of the stream, that is to say the web app that supports this, causing it to change to the relevant page, the relevant character, and highlight the specific stat that is necessary, just drawing attention to it so that everybody knows what's going on.
Yeah, that's what
That pretty much covers it.
That covers it. That's where we're headed. We are in the middle of implementing SignalR on it, and it is not working. We're trying to figure out why. So that's what we're doing right now. We are. So I'm wondering if I change this. I want to play around. I think, and I feel like I'm kind of not. I don't have a clear connection in terms of what the solution to this is. I kind of feel like I am floundering a little bit around about this. But I'm noticing that I've got this, in my Mr. Announcer Bot Hub, I've got this user has coins piece in here. And I know that I am calling, let me go look at user has coins here. Let's go find that. This is a piece that we've been calling around from before. And I think that I've got this, let's go look at.
Yeah, we've got a couple of SignalR hubs out there for a couple of different purposes, and we've had sort of two different types of communication, and I think maybe we've just lost touch with quite why we had them. Some are sort of the methods being called are defined in purely on an interface, which is sort of we're using generic sort of SignalR hub of T, so to speak, and others are more explicitly defined in the implementation. So it's a question of trying to remember exactly why we chose one direction rather than the other. And I suspect in this latest implementation we may have perhaps picked the wrong method simply because we haven't done it for a little while. Yeah.
So what's happening over here is we've got in our Mr. Announcer Bot Hub connection here, and this code works. We're calling invoke async user has coins on Mr. Announcer Bot Hub. And if we go over to Mr. Announcer Bot Hub, we see we've actually got the implementation inside of there.
Yeah.
Right? We are in our, where did I put this? I haven't put it apparently in either one of these. Is that my problem? And I'm actually thinking we might want to follow the model that you were suggesting at the beginning, Rory, where we do the A to B to C kind of model, because we know that that kind of works. I was thinking I could skip that, but I think I'm not going to be able to skip that.
So let's see if we can remember what that is. So A in this case is the WPF client, B is the hub itself, and C is the selection of clients which are listening to messages coming from that.
Yeah. That's what I think it is. So what I'm going to do is I'm going to follow the example that we've already got over here in Mr. Announcer Bot here. So we're basically hooking up to Mr. Announcer Bot Hub. We're calling user has coins on it. That means in our Mr. Announcer Bot Hub here, we need to add the two functions that we are calling.
Just before you go in that direction, we've got a little hint from the chat room. Will Bennett's suggesting that there might be a clients.all that we can use instead of the invoke async. Now, if that is the case,
yes, that's it.
That would be
that's totally it. Yes,
simpler.
Let's do it. That's it. That's brilliant. That's exactly what the smart me would have said. All right.
Love the chat room.
All right. Yeah. No kidding. Yes. So exactly. Yeah. We don't want to do this. All right. We're going to kill that. Let's preemptively kill every instance of Chrome that's out there as well, because we'll need that. So we're going to say clients. What is it?
Clients.all is the suggestion.
Yeah, I thought I'm looking for, it's uppercase C. Is that why I didn't see it? What's going on here? Let's see here. This is the hub connection. Oh, I don't think we're going to be able to do it. is the answer to the question. I think we're going to have
No?
to do invoke async because we don't know. Yeah, I don't think it's going to work, is the answer. Yeah, it's not going to work from our hub connection. So we're going to have to keep going with invoke async. So yeah, had we had more references to that, I think we can make it work, but we're going to have to instead go with this instead, is what I believe we're going to have to do. So we're now going to have to implement player page change and focus item. I'm just going to grab these signatures here since they're the same. We're going to go over into, this is CodeRushed hub here. Let's change this to Mr. Announcer Bot hub. We're going to do that. Mr. Announcer Bot hub. Let's go grab that. Come in here. And now we'll be able to do, we're going to be able to make that call. So we're going to say clients.all that and this. Okay? Feeling good
Cool.
about that.
Yeah, that seems to have accepted that. That's good.
And then we're going to do the same thing here with focus item. And pass in item ID. Okay, good. So there's that. This is our A to B right here. Our B to C, I think we already wrote, essentially. I almost feel like this is going to work.
Well, for those that have never seen this before, this is going to look like magic. Certainly if you've never seen SignalR before, because we're effectively going to instruct a web page to do something from a WPF app. And that just sounds crazy, right? But it's going to work.
Yeah.
Yeah?
And we're going to overlay it live on top of the stream so you'll be able to see it.
Indeed.
So let's see. We are compiling. You can see right over there to my right. There's the build. Getting the run going. And I killed every instance of Chrome already. All right, here we go. Things are starting to show up. Here's our WPF app. Here comes our overlay right now. I'm going to go into inspect. This time I'm hoping to see something in here when we change pages over here. Nothing, still nothing. Okay, but we've got a few more breakpoints we can set.
We have places we can be now, yeah.
Let's set a breakpoint here and here. And we've got, I think we've got still our breakpoints in connection.ts. Those are there. Mm-hmm. All right, so what's going on? Not even getting to that. Let's go out here. Let's double check this.
Are they both? Well, no, actually, one is still supposed to be CodeRushed hub, and the other is Mr. AnnouncerBot. So that is valid.
Let me just double check the over here in Mr. AnnouncerBot what we're doing. In Mr. AnnouncerBot, we're grabbing Mr. AnnouncerBot hub, and over in this one, we're also getting Mr. AnnouncerBot hub, which looks exactly the same. I think that spelling is correct.
Okay, so starting with our XAML app, as we have on screen here, we have very specifically got calls, strongly typed calls to player page changed and focus item, which in turn grabs a hold of the connection that we've got, which is to Mr. AnnouncerBot hub, and sends a specific message detailing the specifics of that operation direct to the hub. Next step should be the receipt of that message at the hub.
Yeah, it should be. So we're invoking async on Mr. AnnouncerBot hub, player page change. Let's go look over that. So Mr. AnnouncerBot hub, we're not getting this ever called. Is it because it's not public? Could that be my problem?
That's interesting.
Let's see if that's the case.
What's the default in C#?
It's private.
Okay.
If you don't specify. All right, let's see if that's my problem. AnnouncerBot commands. Did I need to come in here and do I need to add those two or not? Wait. User has coins. I think I can just simply invoke on it anything I want. Right here is what I think I can do. Because user has coins, it's not part of this, is it? Oh, it is. Maybe I need to put that in there too, as far as the signature. Maybe those are the missing pieces right there. Let's do both of those things right here. And we'll do that. Oh, and we should also have them return a task as well.
Mm-hmm.
Let's go look at it one more time. And let's go over here. Oh wait, no, but these are void. User has coins here is a void. Isn't that interesting? We did not need that before.
Isn't the task the definition of whether it's been sent and sort of its success level? So even if you're instructing but don't want anything back, you still need to know that it reached its end destination. So it's probably like a SignalR wrapper around the voidness of the operation. That's partially why you cannot have a return value, because there is already a return value, which is the task's success level.
Well, I don't know is the answer. Now, Will Bennett saying, don't you need the invoke async in Mr. Announcer Bot Hub now? I just hit run, and it's building, but let's take a look at that. And where in Mr. Announcer Bot Hub? No, I don't think we do. I don't think we do. This CodeRushed Hub, this is where our listeners are. That's our app out there that we're listening to, I think. So that, I think, is working, or should work. Let's see how we're doing now with those two changes we made.
More public than we were, I think, is the main thing, and also have the right, theoretically right signature with the task being returned.
Yeah. All right, so now let's, I've got the app. Let's change a page. And nothing here. This is not getting called. User has coins is called from the invoke. Why is that the case? Why is that the case? Okay, well, I think we can kind of, the only thing we can do at this point is go through, look at, kind of trace things through step by step, look at the pieces that are working and compare them with the pieces that are not, right?
Yeah.
So step one is we got a hub connection. We make this call right here. That bit of code, let me go ahead and I'm going to kill the app and take a look at that. We'll just kind of look at this one piece at a time. We have this, we have the call to start async. That's all happening in our constructor right there. This line of code, just for comparisons, I'm copying that, comparison's sake, copying that to clipboard, coming over to the code here, and these are the same, those two lines of code. So that's the same, and then we have the call to start async. And we call invoke async on it, passing in the data, player page changed. That's the hub connection for Mr. Announcer Bot Hub. Which should get us here.
Yeah.
It feels like it should absolutely get us here, but it's not getting us here, and I'm not sure why. User has coins is, so interestingly, user has coins. We have commented out some code that would normally call that. I was thinking, could we uncomment that code to get a call there to see it working from one and wonder, ask the question, why isn't it working from the other?
Probably not the best time, Mark, but I'm afraid I've got to go.
Okay.
I have to catch up with you tomorrow. With any luck, my mere exit will trigger a thought, perhaps, that will in fact lead to the solution here.
Yeah.
So, good luck, mate, and I will see you tomorrow.
All right. You know what I'm going to do? Thanks, Rory. We'll say goodbye to Rory. Thanks so much, Rory, for being here. I'm going to do this since I think I'm at a point where I need an idea that I haven't tried yet. I'm not sure what that idea is. What I'm going to do is I'm going to stop work on this right now, and I'm going to instead start work on another thing that I wanted to do, which is with regards to the emitter. So let's do this, and we can do this work, I think, while it's running. So let's go back. We will kill every instance of Chrome that's out there, start up one more time. And what I'm going to do is I want to work on the particle system. And one of the things that I need to do is I need to be able to highlight a rounded rectangle And I want to highlight that both with contrast. So I want to make it high contrast and lower the contrast of everything else around it. But I also want to have this kind of magical kind of feel to it. And to do that, I want the particle system to be able to send particles out from the outer edge of that rounded rectangle. And so we can review the particle system here real quickly. If I come in here and we type in test orbit, like that, there's, for example, something you can do with the particle system there. And if I, this is, whoops, hold on one second. This is happening here, but we can also, well, here, we'll just do this full screen for now. There you go, test blue ball. There's also test purple magic, I think, as well. We'll let purple ball run for a while, and then I'll show you this. So with the particle system, we can give it a gravity, we can give it a wind, we can create a certain number of particles per second, we can give particle sizes, we can give it a target hue, target brightness, target saturation, and we can give it variance on all those. So we can say, well, we want your size to be 5 pixels, but you can vary plus or minus 100% or something like that. Test purple magic looks like this. There, it's that little burst right there. Oh no, wait, that was purple burst. Hold on. Test purple magic is this one right there. Just kind of shoots that over the top. So that's the particle system. What I want to do is create a particle system that creates particles on the outer edge of a rounded rectangle. And so let's do that, or at least the outer edge. So let's go back and look at the particle system here, which is over in TypeScript. And it's in the game engine. And inside our emitter, we had created, I think, a couple classes here. We have a rectangular particle generator and a circle particle generator. What I want to do is I want to create, one of the things this does, both of these have a function inside of them called get particle position, which is going to return a position plus a velocity. So it's going to tell me an initial particle position. And what I want to do is I want to be able to say, hey, if we're given like a radius, I want to have an option that says how far away from that radius edge are we going to allow particles to be generated? What's the variance? And if the variance is 100%, then it'll go all the way from the center of the radius out to the radius, and particles can show up everywhere. But if it's 0, I want all the particles showing up right on the radius, right on the edge of it. So I want to actually implement this for the circles first, then we'll do it for rectangles, then we'll do it for rounded rectangles. That's what I want to do. So for the circle, let's take a look at this. We'll refresh our memory in terms of how this code is created here. Let's see. So the offset here, we get a random position out here, and then we do this right here, random max of radius, plus our non-zero offset, which is very, very small right there. The reason we do a non-zero offset, at least initially the reason we did, is because we were using that offset to also determine the initial particle direction vector in where it would go. So if I'm having the center of my emitter here, I'm putting a particle here, that means my particle is going to be shooting out that direction right there. And so I add a non-zero offset here. Let's do this. Let's go in, and instead what we want to do is we want to ask the question, we want to say, how am I going to do this? I think it's a new parameter that we're going to pass in here, is what I think we're going to pass in. And so let's look at this. Let's put all these on one line so we can see them. So we're passing in currently position, velocity, particle initial velocity, initial particle direction. And I think what we want to do is we want to also specify, the this range that I'm talking about. Let's put a marker here, drop a marker there, and we're going to create something that's of type target value. And I think I want to call this particle generator particle radius, whoops, particle edge spread. That's what I think I want to call it. So particle edge spread. And now what I want to do is in the constructors, I want to come in and say, let's say this dot particle edge spread is equal to new target value. And the target is going to be 1, 1, which means 100% spread, okay? And the relative variance is going to be 0, which means it's always going to be that. I can also specify its low bounds and high bounds on that, which can be a number between 0 and 1. So that's our new particle edge spread. And then that means we want to pass that in. So let's go back to that marker. And let's add that as an additional parameter. So say the particle edge spread, we're going to pop in there. Emitter edge spread. Emitter edge spread is what we're going to have. We're going to call it. Okay? And get new particle position. Add that parameter as well. That is of type target value. And let's add that everywhere else we've got this. So get new particle position is here. Add it there. And it's down here. Add it there. I'm just using CodeRush's tab to next reference to get to all of these here just very quickly. Okay. So there's our particle edge spread. Let's play with it first in the circle particle generator. So basically that's the, let's create a new number here. This is going to be our particle radius, distance, I think, like that. And we're going to, if we make no changes to the code at all, it's going to be equal to that right there. Okay, oops, like that. Hiko Panjas is now following. Thank you for the follow. Good to see you. All right, so we've got particle distance right there. That's with no changes. If the spread is 0 to 1. What we really want to do is, instead of saying random max, which gives us between 0 and that max value, we want to say random between, and we want to pass in two numbers. We want to pass in radius as the high number, and the low number is going to be radius minus, radius times emitter edge spread dot get value, which is going to give me that number between 0 and 1. And if the spread is 0, we actually want it to be 1 minus that, I think. So if our spread is 0 on there, it's going to be 1 minus 0. No, wait, hold on. The spread is 0. This is not radius minus, I think. Yeah, hold on. This is the min value, right? Let's see if I got this right here. This is our radius minus the spread. Yeah, I think that's right. So if the spread is 0, this is going to be equal to the min value for the random call is going to be equal to radius. And if it's 1, then 1 minus 1 is 0, which means our min value is going to be 0, which means we can show up anywhere. The particle distance can be anywhere inside. And so if it's like 20%, 1 minus 0.2 is 0.8. 0.8 times radius is 8/10 of the way out the radius. So the minimum value is going to be 8/10 of the way, 80% of the way out. So 0.2 gives us that. So I think that's exactly what we want. And so that's going to give us our particle distance right there. We're still adding this non-zero offset. I'm going to keep it for now because it's small and it's, in terms of pixels, it's not a big deal. And I think that is, we can put all this in one line of code right here. And so I think that's going to do it for circle for us. So now if we go out to our dragon game, I think we've got some test pieces out here. So if we look at, for example, let's see here. Let's bring this on screen, and we're going to do, if we do test, I think we should create a new one. That's what I think we should do. Let's create a new one. So, because I kind of like these that we've already built out here. So let's look at, I think I'm not going to have, let's base it on Purple Magic, I think. And let's come in here and we're going to call this our edge test. Like this. And the emitter, I'm going to make the emitter bigger so we can see it. But now I'm going to come in and modify the that emitter edge spread. And we're going to say emitter edge spread. Well, actually, we should do a test first of all, just to see how that works. And then we'll make a change there. So let's go back, look at these. Here we go, orbit. And this is going to be the, we're going to call this edge, like this. And we just need to change this right here, edge test, like that. Okay, and let's save that. Let's come out here, refresh. Let's just see what it looks like to start with. Looks like Will Bennett already got it out there. There it is right there. Okay, cool. So we just saw that. Let's give that, let's make some changes to that. Let's give it our initial velocity. Wait, emitter. Here's our initial velocity right here for the emitter. Let's make it -9 and -13, like that. So it'll be a higher. Let's turn our emitter gravity down. Let's turn it down. Well, actually, let's not turn it down because we just started our initial velocity. We're going to do that. Let's now, so if we look at that, here, I'm going to save, refresh, send it out one more time, test edge. Did you get it? I'm not sure if Will got it or not. There it is right there. So you can see the particles are coming all through the middle of that thing. What I want to do now is if I make this change to the emitter spread and I say that's equal to, or just say emitter spread dot target equals 0. So now the spread's going to be 0 on that. Let's see what happens. Refresh. Got the command ready to go. Here it comes. Cool. That's what I want. See the circle? That's really cool. That's totally what I want. There's the edge spread. That means if I come in here and say, well, I want it to be 0.2, it should be a thicker ring. Let's change particles per second to let's do a couple other things. Let's take gravity down to 0 on this, so it's just on screen and doesn't move. Okay. Let's kill this piece right here. Let's put this at, put this in the center of the screen. Although 1200 is off screen, 1080 is what we want. And we can still have particle gravity, so the particles will fall. Let's save that. Let's refresh. Come in here, do a test edge. As soon as it is done loading, there it is. Okay, cool. So now that is that with the 0.2? Is it a little thicker? There it is. It's a little thicker. Okay, cool. Change it. Let's change it to a 0.5. And then we're going to come back and we're going to refresh. And when it comes in and loads, here it comes, thicker. So now it's going halfway between the radius and the center. If we come back in, let's make the radius bigger so we can just, really visually see it. We'll make the radius 120. Particles per second will go to 1600. So we'll create the particles right here. We're still at an emitter spread of 0.5 or 50% of the radius. Let's refresh that. And here it comes. There you go. So kind of cool. Very cool effects that you can create with this. Okay, so we've done it with the edge test. This now works with the radius. The next thing we have to do is with the rectangles. So that'll be the next thing. Actually, I think I want to turn off gravity a second. Let's turn off particle gravity. So we'll just do that. And I think that's all we need to do. Let's watch this for a second with no gravity. What? Why do we have gravity? Is it because of do I have to say 0? I'm not sure. That feels like that should have worked. There we go. Cool. So this, I think, could look kind of cool in terms of highlighting something if these effects were subtle and if we drop the overall opacity of the elements. Let's play with that. Let's add a new property to do that. Let's look at the emitter and how we're actually rendering. Render for each particle rendering, and we go into super render. Yeah, so the render of the particle, we jump into that. There's the particle render. Calculate opacity call is here. Multipliers number. Percent particles to create, multiplier, and then we have the multiplier down here. I think what we can do is this. We can add a new property over the emitter that says emitter.overall particle opacity. Particle max opacity. Like that. And then down here, we're going to say it's times equals that. Wait, is that right? Percent particles to create. Yeah, I think that's going to work. I think that's going to work. Okay, so now let's declare that inside of emitter. So let's go to emitter. That is when it's stopping. Yeah, I know it's when it's stopping. I think it's still going to work. Well, I think it will still work. Particle max opacity. We're going to come in here. We're going to say initialize it to 1. Oops, 1. Like that. Then we're going to come into our test and in the Dragon game, and we're going to cut it in half. So we're going to say this dot emitter dot particle max opacity is equal to 0.5. Okay, and now we're going to do an edge test again. So let's come over here. Here you can see it for comparison. There it is right there. You see pieces are coming out at full opacity essentially right there. And that's how high contrast it is. Let's refresh. And let's do a test edge. And there it is. Nice. So now we can have something like that and to highlight. And so if this were behind, for example, were behind one of the elements here, for example, the AC, if it were behind the shield, and we're in the same kinds of colors as what we have here, there'd be this small little motion effect there when we're talking about it. So it's something I want to play with. Normally I don't ever use motion to highlight, but because the particles are small and because we have control over opacity and size, I think we're going to be able to give it a kind of a magical effect when it's selected. So that's the idea there. The next thing I want to do is rects and rounded rects. I don't have a rounded rect generator yet, but that's one of the things on my list. Rectangles, the next thing I want to look at here. And I haven't really given this a lot of thought. That's why I started with this one right here. I'm going to change this back because I'm actually a bigger fan of the full opacity there. Now let's go back up here to emitter. And so emitter defaults to a circle particle generator. But if you come in and set call set rect shape, it will create a new rectangular particle generator for you automatically if we call set rect shape. So let's do that. Let's go over here and we're going to come in and we're going to say this dot emitter dot set rect shape. Whoops. This dot emitter dot set rect shape, and we're going to pass in say 400 by 133, like that. Okay, so there's our call to set rect shape. We don't need a radius anymore. That's not going to do anything right now. We'll change that to 0. Nothing's going to happen now because we haven't built that yet. But let's go ahead, and we haven't added that code. But let's go ahead and do a refresh just so we can see it. There we go. So that's what it looks like there. So it's generating anywhere inside. Now, one of the things that's not great about this is that the velocity that it's picking for the items, or the initial direction that it's selecting for the items, it's all based on subtracting from the center point of the rectangle, which means there are a lot of pieces that are more predominantly moving away from the center, and it's still got this kind of center-ish look to it. And what I would like to do is, I think maybe the first thing is let's figure that out so that our particles are going not from the center, but from essentially a center rectangle inside of this rectangle that's essentially scaled down by the smallest dimension, whatever it is. So if my smallest dimension is the height, I'm going to scale down and essentially get a line right in there, like that is what I'm going to do. And then what I'm going to do is I'm going to find the direction between the closest point on that line and the point where the particle is, and that's the direction I'm going to use. So right now, you've got a sense of what this looks like, right? It's very much, it's kind of distorted. When we're done, it should look much more like a rectangle, the particle flow. So that's what my next goal is here. So there's that piece right there. What's interesting is I want to do a refresh here on the. I'm trying to figure out why we're not seeing particles here over the stream. I just want to try this here. Test to edge as soon as this is done. It looks like it's done loading up. Yeah. Why are we not seeing that? Oh, that one works. Maybe I need to refresh the cache. Let's go in and do that. So I'm going to refresh the cache on in OBS. I've just done that. Let's do a test to edge again. There we go. Cool. All right. So that's live over the stream now. We should make that a little smaller and put it off to the side a bit here. Let's do this times 0.7. Move that to the right a bit. And let's make this maybe 300 by 100 for now. Save that. This should be enough to refresh it. And do another test edge. There's the test edge. Okay, it's off to the side there. All right. So that's what we want to fix. That's what we want to change. So the first thing I want to do is get the center, see if we can figure out that initial velocity, figuring that out. If we go to rectangular particle generator, get new particle position, get initial velocity. So this piece figures out the initial velocity. Where's the initial particle direction? Is there, right here. What's going on there? So initial velocity is going to be that velocity vector. That's where it's going. So if we go to super get initial velocity, here we are bringing in, let's see who's calling this. It's called from the circle particle generator as well. Okay, so here's the code here. We're going to basically replace that code with something else inside of our rectangular generator. But I'm going to copy it and bring it down here. And let's see what we've got here. Reminding myself of the code we wrote for this. Velocity offset is, we initialize it to there. We check to see if length is 0, then it's equal to the offset of that individual piece. And this is the thing that we need to, so this offset right here works for circles. In other words, this is the offset from the center. That's what this offset is. What I want to do is then calculate this differently. That's what I want to do. And I think the code is, this is the code we need to change right here. So we need to do a subtraction. We need to do two things. We need to get a point that is closest to, I don't think I have, I guess I can do this as a vector. So I can say, I think I want to do, all right. So let's do two things here. Let's first of all see if we can find some JavaScript code that is the closest point in line to point. I think find a point on a line closest to a third point. That's what I want. That's exactly what I want right there. So I've got a line somewhere out there, and I want to find the point on that line that's closest to the point I'm on. I want to find like this point from here to here. That's what I'm looking for. Get closest point on lines. You'll need a normal to the line is what Will has said. Yeah, I think I'm going to, I think that once I get that, I'll just subtract, I subtract the point I'm interested in from that point, and I'll have the vector I want. I'm not sure I'll need the normal, but let's take this and let's run with this, because this is like, it's a lot of code, more than I was expecting. And implement the dot product. Is there a faster, easier way to getting what I want to get, is the question. So this is where I'm going. Well, let's go here and we'll see what Will says as we move forward on this. I want to get out into vector, I think. Use the dot product to project the point onto the normal. But I still need to find need to find that point that on the line. So in other words, what I'm going to do here, hold on a second. Let's just make sure this is absolutely clear visually. So let's create a new page here, new slide. And let's come in here and grab a rectangle. So this is my outer rectangle. And then what I'm going to do is I'm going to say, well, okay, let's take our smallest, dimension, cut it in half, right? And then essentially create a line that goes like this, is what I want to do. Okay, like that. And now what I want to do is, let's say there's a point out here. Okay, so here's my point that I'm bringing up here. I want to find the closest point to this point. Let's change that to white so we can see that. I should probably move this so it's not right overlaid and obscured by this. So I want to basically find the closest point to this line right here. So first step is I've got to calculate this line right here, right? Which I think shouldn't be too hard. I'm just going to find this dimension right here, whatever this is. And I know my center point already. So I basically just got to take the longest dimension, subtract half of the, or subtract this other dimension from it. And that's my width right there. So I know these 2 points here. So this line is not hard to get. So then what that means is I'm going to find the closest point from here to here, like this. Oops. Like that. And then what I'm going to do is from that, I'm going to get my vector, my directional vector, which is going to be completely, essentially the opposite. So if a point is created there, it's going to come out here. And I might think, well, you know what, let's do this. I might say, well, you know what, with regards to where we are closer over to the edge, so I might give it more of an angle out a little bit. So I've got more of a distribution. So, because then I think what then I'm looking at with this algorithm is I'm looking at a bunch of these like this. Whoops. Right, where particles are shooting out like this to here, and then they start to angle out as we. So I didn't want to do that. Let's do that. And then, only then do they start to angle out, where we go out here, and here, and here. So I'm not sure that I'm going to like this more, I guess is what I'm saying. And there. And so each one of these is kind of doing a line back to this point right over here, like that. So choo-choo-choo all the way through and out there. I think it's going to make it better. I think it's going to be better. So at least we're going to go there. So that's kind of where I'm going. So my thoughts are this. I calculate this line first, find the point closest here, right here. Then once I get that point that's there, I subtract this point away from this point, and that gives me essentially the vector, the direction that I want to be going. And then I say, okay, and then that's my offset. That's my thinking on this. Okay, so with that said, let's calculate the points for that. Well, wait, let's get the code. I think I had this on the clipboard and I probably killed it after editing there. So I think I want to put this in vector is what I think I want to do. So let's go to the vector class. See what we've got in here. Closest point on lines. What's PXY? That must be our point. Got it. Okay. I think I need to create a point. And what's AXYS? Is got a length axis. What is that? AXYs. It's indexed by n-1. Get closest point on lines. It's on, wait, for multiple lines? Let's see what's going on. Maybe I misread this. Let's grab this comment, pop this in here and take a look at it. Huh. Yeah, I think there's something simpler. Here we go. That's more like what I was expecting. Okay. Oh. All right, so let's see. Will Bennett says, hard to explain but simple to implement. If you subline end, if you subtract the line end from the line start, you get a vector from start to end. Yes. You then do a new vector and normalize it, which is the normal to the line. You then need the distance to the origin, which is normal dot start. The distance to point P is then P dot normal minus distance to origin. Point on line is then P dot sub. Point on line is normal multiply the distance. All right, let's look at this. Let's look at what Will says and see if we can work through this. Even though I've got this code right in front of me and I feel like I can do it this way. Let's see if I can do it, what Will is suggesting here. And we'll let you guide us through this. I'm going to undo this. I'm getting rid of that. Okay. Let's stick Will's comment in here. Need to implement dot product in vector. So I'm going to need some code for that because I'm not at all remembering what dot product is going to be in terms of what that's looking like. Let's see if we can find that. Let's see if Will can beat us. Vector dot product. This, oh really, that's it? That's easy. Okay. All right, so let's do that. All right, so we're going to say, we're going to create a new function in here called dot. It's going to take a other type vector. That, and then we're going to say return a new vector of this dot x times other dot x. Oh, wait. It's not, it returns a, it's not a new vector, is it? It returns a number. Okay? All right. Okay. So we've got the dot there. Then need the distance to the origin, which is normal dot. Hold on. And normalize it. Okay, hold on. Line end from line start, you get a vector from start to end. Create a new function and start adding the code. No number. Yeah, we got that. Create a new function and start adding the code. The new function for Yeah, let's see what we're going to call that, I think. Let's look at get the client code here. Need a point and then the start point and the end point. Yeah, I think that's kind of where I'm at. Let's figure out the line in the middle here. So we're going to come in and we're going to say, we have our height and our width. So we're going to say get smallest. I think we need to check to see, so if this dot height is less than this dot width, then we're going to say it's short and fat. Okay. Else, if it's the other way around, it's tall and thin. Else it's square. Like that. Okay, so we have those pieces right there. The next thing I need to do is, and all of this I'm trying to get point 1 and point 2. And I think I'm going to have to create a new class called point. Do I have something out there? This is everything we're doing is from scratch. What do we got? Looks like we built this. Okay. All right. So cool. So we're going to say let pt1 equal of type point dot, and then we're going to have a pt2 as well of type point. So those will be our 2 points. So if we're here, then we're going to say our pt1 equals new point hold on. Do I want to back it up? Hold on. Maybe instead of doing this, hold on, I know I just said this is what I want to do, but what if I wanted to do something like this? Kind of our dev is now following. What if I wanted to do this? And instead, so that would give us basically kind of a way of spitting out that is like this, and then we kind of come out again at the edges like this. I guess what I'm thinking is, what if I want to find the closest point in this inner rectangle? Because I think even for a square, I think I kind of want to do the same kind of thing. Like if I have a, let's just move these over here. Look at this a little bit. If we start coming in. Here, let's do this. Let me just create a new square. So I guess the idea is, what's cool about this is I guess there's 2 things I'm comparing here. My current strategy, the problem with my current strategy is we've essentially got a really tiny square in here, which means the way the particles are going to go when they shoot out is it's going to kind of look like this. Like this. And it's essentially going to be radial. It's going to kind of look radial, I think. That's going to be right there at the diagonal, which is okay. You know, as I'm looking at it, I'm thinking, is this really a big deal? And is there a difference here? And if we change it to this, then what happens is what? These are not shooting out so much here. What happens instead is these are more like this. And then just right in the edge, it's like, I think I have a basic problem with the way I'm approaching this. Yeah. Okay. So I guess or maybe I don't. I guess what I'm saying is I think this is actually going to work right here. That even if we do drop it all the way to 0, I thought I might have a problem, but now that I'm looking at it, I think the way those particles spread is actually going to look good and be okay. It's going to kind of be all the way around there. So it's okay. I'm going to go back to I think it's okay. Yeah, I guess I'm worried about this area right here. I want to make sure that's a smooth distribution in this corner and this corner. Yeah, do I get a smoother distribution with this? Here to here, I think I do. All right, well, we'll find out. We'll go ahead and do this for now as the way we're doing it, and we will we'll continue. All right, so we're working on getting those points. So if the height is if it's short and fat, here, let's put this down here. If we're dealing with something short and fat, then our y distance is going to be equal to 0, and our x distance is going to be equal to this dot width minus this dot height, all of that divided by 2. That's our x distance, which means our point 1 is going to be yeah, I almost think that we can do this. We can come up here and do this, calculate only these distances, and down underneath here, we can pop this in here. So we can say, so we're going to say x distance is equal to that. Here we're going to say y distance is equal to height minus width divided by 2. And in the event that we are square, then it doesn't matter. And so now our point 1 is going to be negative x distance, comma, negative y distance, and our point 2 is going to be positive versions of both of those. Like that. There's our point 1 and point 2. Okay, so now that we've got those, we now need to find out the point that's closest to the line represented by these two. So can we, yeah, I think we can create a, we can do something like this. Point 1 dot, not exactly sure how I want to do this yet. New vector. I could use these as vectors too. I could create these as vectors. Let's try that. But that's going to give me the line. That doesn't give me the piece between the two. It's not going to do that. Okay. So, so what I got? Zindictive is now following. Do I have a line? Did I create a line out here? Where was I? What did I do? Page up, page down. There we go. Is this mine? Did I do this? Yeah, it looks like that's ours for sure. We wrote that for sure. There's our CodeRushed image embedding right there. Okay, so we do have the line ability. Wait, does line have intersects with, extend equals matches coordinates, test masking slopes, test extension, run test? Nope. I was hoping that we had something that said, I've got an intersects with, but I don't have a closest point yet here. Okay, so, but I think we can put that in there is what we can do. So let's come in and we're going to say, let closest point equal line, so new line of PT1, PT2 dot get closest point. And now I want to pass in offset, I think. And maybe I will add something in here that says like 2 point, like this. That just gets, it converts the vector to a point, I think, because I think I want this to be accept a point. So let's go in, let's declare this. And return new point, this dot x, and this dot y. That. And then we're going to call get closest point on the line. And let's declare that. And here's where we need something like this. And all right, hold on. Let's go over. So I'm going to use this, Will, is basically where I'm going. So this is kind of the direction that I'm kind of feeling this in terms of where we're going on this. B. So C is the result in this code right here. So we're going to come in here. This is going to return a point. So we're going to say let C point, like that, equal, or let's do this instead. Let's do CX, CY. Let's change all of these to that. Got any other C's in there? I don't see them. Okay. And then we're going to say return new point CX, CY, like that. Okay. And next, let's change this to B, and then rename it back to test point. And let's create a, I'm just doing this for now, just so I can do a quick rename on this to this, and then get rid of that. Okay, and so now, oh, where do we get this P though? Oh wait, we're in line. Hold on. So this was, let me go back. It was incredibly clever until I realized it was wrong what I was doing. Okay, hold on. P and A, I think, is there any documentation out here on that? Nothing on these, P and A. I'm pretty sure those are just two different points on the line. Oh, here we go. Wait, A and P. C, C, A, B. Okay, hold on. Let's go back even further, because that was B right there. A and B, P is the test point. Got it. Okay, so P, this we want to rename to P, and then that's test point. Got it. A and B are the two different parts of this. It's just P1 and P2. So A, we're getting there. All right. A like this, we're going to rename this to P1. Okay. Yep. Good. Kill that. Do the same thing over here for B. Rename this to P2. There we go. Let's come in to P1. Rename this to this dot P1. So now we can get rid of that. Okay. Now, how are we doing? Better. 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 Okay. So that's the closest point now. We're going to get closest point online. Okay, cool. So there's get closest point online. Now that we've got that coming back online, we basically want to do a subtraction here. I'm wondering, though, what's interesting is I've got like these line functions, and they kind of do have a between a starting and an ending, whereas vector is just really kind of an offset, essentially from the origin. So I was wondering if I should consolidate those, but I'll keep these separate for now. Closest point on line, so now we've got that as a point right here. And now I want to take my offset, subtract it, that point from it. So I think what I want to do is I want to say, and I think that's going to be my new velocity offset. So I think it's like this, is offset dot sub, hold on, closest point on the line, that offset dot, I think I want to create a sub point is what I want to do. Because I'm not really subtracting a vector from it, I'm subtracting a point from it. Or, hold on, do I have a subtract? I do. Let's just do subtract. Let's do closest point on line and then call toVector on it, like this. Let's add a toVector piece on it. So we've got it. We can take a vector to a point and a point to a vector. Really? I thought I declared you. Declare method to vector. What's going on? Closest point on line. It's a point. One more time. Make me do it. Okay, what's wrong with that? Why aren't you working? Huh. That's weird. So it was working, but kind of not. All right, so there's toVector right there, and then we're going to say, this is going to return a vector. We're going to say return new vector, this dot x, this dot y. All right, I think we're almost ready to test. So the whole time we've been seeing this array where you see this kind of, it looks fatter in the center and kind of thinner on the sides. What we're hoping is it's got a more even shape. Also, the other characteristic of this is right in the center, you see like everything's kind of coming out of the center. And so you kind of get a sense of that shape. So we're hoping to even that out with this change here. So now we've got offset, subtract, and so now our velocity offset is now headed in this particular direction. It's not normalized. Do we need to do that? Oh, no, wait. Oh, no, we're good. It is normalized. We're dividing by the velocity offset length. So we're going to be okay there. So I think that's going to do it, is what I think is going to do. Let's do a refresh and see what happens. Let's do it. Do I have, are we running? Where is, there you are right there. Let's do a refresh over here. See how it goes. Here's the entire function. Let's see what Will has helped us out with right here. Okay, so let's see. I'm doing a refresh over here. It's taking a while to reload. Let's see what once this comes up. We'll send a test edge out. Then we'll take a look at Will's function that he gave us here. Test edge. What's going on? Why is this taking so long? Do cache hard reload. Is that going to get us any better? All right, let's try this. Duplicate the page and kill this. Any better? It's not responsive if I right click here. Kill Chrome, restart. Okay. Boom. Boom. Let's restart. Yeah, I couldn't bring the question that Will's asking, are there errors in the console? I couldn't bring it up. I was right clicking and there was no menu option to bring up the console. So we'll start it up one more time. See what happens. Now I can come in and do inspect. What's going on? There we go. Okay, we're done loading. Let's do test edge. And it's off to the side. Does it really seriously not look any different? It really doesn't. It looks a little maybe different. You could maybe convince me that, but I'm not entirely convinced. Let's look at the code. Let's set a breakpoint here and see what's going on. Yeah, I was expecting it not to be so bulgy in the middle. Yeah, it's not here. The center, that line is going to be here. Yeah, these should kind of be coming up more at a higher angle here, I think. So let's see what we've got. Set a breakpoint here. Why can't I set a breakpoint? There we go. Set a breakpoint here. We're not getting any of these. It's my rectangular particle generator. Oh. It's because I'm calling super instead of this. That's going to maybe make a big difference. Let's clear these two breakpoints here, do another refresh. Okay, so here we go. Here's the refresh. And do test edge. Ooh, yeah, good suggestion. Will probably draw the line. Okay. The line is too long. Why is it too long? Cool effect, though. I like the effect, but like mesmerizing almost. But it should not be. The line is too long. Why is that? The x distance is, so for short and fat, width minus height. So there's the distance. The x distance out is width minus height. So that's what's left. Hold on, let's go to the visual on this thing right here. So if we're here, we say width, this, minus height, there. So that's going to get us to yeah, I'm expecting it to be, hold on a second. So this distance from here to here, and I want to divide it by 2. So I'm basically saying, totally blanking out on this. So this minus the width, that, divided by 2 is this, which means we get these two on the sides right here. That's from the sides. The outside edge, actually, this distance is from the outside edge, not the inside edge, I think. The distance from the inside edge is going to be this dot width divided by 2 minus that, I think. This dot width, hold on, this dot width divided by 2. So far I don't want to go. Minus this dot, hold on, I have that. This dot width divided by 2 minus, that's the distance out. Can we set a breakpoint? All right, so let's see what we've got here. Height is 100, width is 300. So we're going to come in here, we're going to say the x distance is 100. Okay, so 200 divided by 2 is, so then we're going to go from the point 1 is at 100. What? Okay, yeah, point 1 is at negative 100, 0. And point 2 is at 100, 0. And the width of this is 300. So there, we should be 50 in from the outer sides of this. If we come over to here, by the way, I think we have a problem with our animation right here. Like if I move this off to the side, I don't need it. I think animation stops and we don't have the recovering. AAV underscore is now following. Okay. I think you need half width and height since you calc from the center. No, yeah, I kind of am, I guess, but I've kind of got that, right? This calculation looks right to me. This 0.1 and 0.2, these are looking good. The closest point, so the offset is what? Let's see what our offset is. Can we get a help on the offset? I'm not sure why I'm not getting any. I just hit F10 and left it. Oh, because I hit refresh out here. Is that why we just lost that? Maybe that's what it was. Okay, let's try one more time. Test edge. Okay, we're over here. This I'm good. I'm good with these two. These are what I want them to be. 100 to the left, 100 to the right. Odd, though, that the y here is a negative 0. That's kind of unusual. I didn't know I could do that in JavaScript. So now my vector, I've got an x and y of about 15 and 29, length of 33. So that's from 0 is what that offset is. But that should be okay because these 2 points are essentially around the origin as well. So between these two, I'm expecting to get something that's got a y-coordinate of 0 and I think an x-coordinate of 15.79, I think is what I'm looking for there. Is what I'm looking for, I think. And is that why we are failing? 15, x is 15, there. So there's the closest point. This offset is already at 15. So the question is, does offset ever get outside of greater than this? And it should totally get there. It should totally get there. We should get to this point. I guess I need to add code here to do something to see if that's the case, just to get into the debugger. But this code is looking good to me. What if I did this? What if I said, just did that and that? Cut them down a bit. Run. I've cleared my breakpoints. Let's refresh. And see if we can, see what's going on here with this. I should have some going in a direction that's not straight up or straight down. That's weird. It just came up like that. Just disappeared. That's weird. In this refresh, this is like the weirdest refresh I've ever seen. All right, there we go. It's done. Okay, here's test edge. Yeah, I have nothing by the edges there. We just did a refresh and it's like a third of it. Let's drop it to a fifth. And I'm not expecting any changes. Save, refresh. There's the test edge. Yeah, there's simply no change, which means our calculation for the closest line seems like it's always going in the. All right, let's do this instead. Let's go back to the times divide by 2. I think you should draw the rect in the line. Fine, I'll draw the rect in the line. How can I do that is the next question, because we are kind of far from a drawing rendering thing, so we need to save this is what I think we need to do. Let's do that. Emitter, we're gonna have to save these pieces right here, I think. Bring them up here. Oh, this is what Will was referring to before. I've got half height already in here. So it's just like this dot half width minus this dot half height. Right there. And then we have the opposite of this down here. This dot half height minus this dot half width, like that. And square, we just keep the zeros right there. So, so there's my this point 1, this point 2, and Will is sad.
Sad Panda!
Sorry about that, Will. I'm sorry you're sad. Hope things will be better soon. Okay, we're going to go in here, this dot point 1, this dot point 2. So now we've exposed these pieces. We have point 1, point 2, rectangular particle generator, this dot particle generator is instance of. We are now going to get into render. And then we're going to say, okay, so if this dot particle generator is a rectangular particle generator, then we're going to say world.context dot move to, and it's going to take an x and y, so we're going to say pt1 dot x and pt1 dot y, like that. Then we're going to say that dot line 2. We're going to go to point 2 there. Then we're going to say world.context dot, what is it, stroke style equals red. Whoops, that's white. Let's make it red, like that. So I got a red line. And then we're going to say, I think it's just stroke is the call, right? Yeah, I think that's it. So that at the very least should draw the line. Let's see if we could draw the line now. Begin path. Okay. I feel like this works without begin path, but maybe I'm wrong. Let's go, we'll do a refresh one more time. And what was that, John Cena? Who's that? World Wake is saying that, asking, is that John Cena? Yeah, that's Mr. Announcer Guy. Mr. Announcer Guy likes to say things every once in a while. Isn't that right, Mr. Announcer Guy? You're a pretty good helper, Mr. Announcer Guy. Yeah, you are, aren't you? Okay, so let's see. We want to go do a test edge. There's my test edge. I don't even see the line. Why don't I see a line? Did I forget? Oh, no, wait, I do see a line. It's up here. Oh, yes, of course, that makes sense. It is up there because we need to say this, we need to take the position of the emitter. It's all relative to that. This dot, what is it? Do I have an X and Y? This dot position dot X plus that. And the other one is this dot position dot Y plus this. That should get us a much better one. Let's refresh one more time. Get out there, do a test edge. And here we go. What? I think I forgot a plus. Yep, I did. Okay. Getting closer. Save. Refresh. Get ready for my test edge again. And it's refreshed. There's my test edge. Okay, cool. All right, so clearly we got a problem because the line is actually calculated exactly like we want it to be calculated. The line is good. I'm going to also say that the rect, I'm going to say the rect is good too, but you know what? Let's go draw the rect. Let's do the rectangle. So that means, I'm going to copy this, come in here. This is, we're going to make this blue instead. And I think I've got to draw a rect in here somewhere. I don't think I need this. What is it? Is it a, what kind of rect stuff do I have? I have a stroked rect, okay? And so X, Y, so the X is going to be this dot position dot X minus this dot emitter, nope, particle generator, sorry, particle generator dot width divided by 2. That's the X. The Y is going to be that. Good. And then we're going to have two more properties down here, which are just going to be the width and the height. Did I change that last one? Let's go double check that. Make sure I did that. Get rid of this. Height. Get this last one as height? Yes, I did. Okay, let's put all these on one line so we can see this. I mean, all these on multiple lines so we can see this. Let's scroll those up a little bit. There we go. All right, so there's my X, there's my Y, and my width and height. Put that down there like that. So there's my stroke width there for blue. Let's see what that looks like. Come out here, refresh. Get ready for test edge. Yeah, so they are clearly, that particle position, where that particle is, the particles are coming somewhere inside that range. Let's make a change here to this for a second though. Let's do, and then we'll still look at this. I want to get, my emitter spread is 0. I'm not using emitter edge spread yet inside of here. I kind of want to use that, but I don't know, I guess I won't do this. Let's look at the problem. Why is that initial offset velocity incorrect? Yeah, that velocity should be pointing, everything that's in these corners, here and here, everything in this corner here and this corner here should be shooting out at the edge. These over here on the sides should be shooting that way as well. Right, so there's something in our subtraction logic here. Everything else looks good to me. Let's go look at that again. Emitter. It's up here. get initial velocity. Closest point on line. I feel like this is my problem. My assignment of velocity offset here is incorrect and wrong. Closest point on line is there. Offset, subtract. Where are you? Let's do this. Let's just do a console log on that. Send it out. Let's go over here. Particles per second. Let's send 1 out per second. And the velocity offset, we're sending that out. And I want to also send out I think I want to send out the offset. All right, so let's try that. See what we get. See what kind of data is out there. Refresh. Test edge. There's the edge. Got 1 particle per second coming out. There's the particles. You can see them right there coming out. Let's bring up the console so we can see that. Should have made the particles bigger so they were way more obvious. Okay, so I'm sending out, what? PT1, oh, I got that. So that I can fix, it's just a diagnostics issue. Okay, so that's fixed. All right, let's go back down to, all right, so let's see what we've got. So we look at this. We have, oh shoot, it's not saying which one it is. I was hoping it would have that name, but that's not what helpful to me. The first one is the offset, the next is the velocity offset. So, and then we have the 3 dots. So this is going to be the offset right here. The next one is the velocity offset. So x is 0. So I think I guess that we're always seeing x is 0 in every single one of these. So why is x always 0? X is here. The first one, I think the problem is, hold on. Offset, subtracting the closest point on the line. Okay. Yeah, so the velocity offset, the x position on the velocity offset, which is the second one after this line here, is always 0. It's always 0, which means for this to always be 0, that means that the x's of these 2 points are always the same. So get closest point on line. Oh my gosh, get closest point on line, I bet extends the line all the way out. That's what I think the problem is. I think get closest point on line is not essentially truncating it, is what I think is happening here. because I'm defining a line segment, not an infinite line. And I think get closest point on line is assuming an infinite line. And so what I need to do is truncate it. That's what I think the problem is, okay? Yeah, well then it's saying you need to output get closest point on line. Yeah, I think that's fair to say. So what I need to do is I need to say ask the question, is it outside those bounds? Is that point outside of the bounds? And whichever one of those 2 points it's closest to, it's that point. I think is the fastest way that I can think of to solve this, or the simplest way I guess I can think of to solve this. So, all right. So if closest point on line dot x is less than, so now I need to get 0.1 and 0.2 so that the one is, but 0.1 is always going to be less than 0.2. Cool. That's awesome. So we're going to rename this and call this the smaller point. Maybe. And this one we're going to rename to the larger point, like this. Okay? So that we know is always the case because the x distance is always going to be positive. So, and so with a y distance. So there's our smaller point, so now if closest point on line dot x is less than smaller point dot x, or then we want to do the same thing with the y's. So if our point is lower than those, then we're going to say closest point on line is equal to smaller point. So kind of, I think, a clever way of solving this. And then we need to do the same thing, but with the larger point check. So if y is greater than either one of those, then then the closest point on line is equal to larger point. I bet that works. Let's see if that works. Okay, refresh. Test edge. As soon as that's ready. And what do we got? There we go. I think that fixed it. All right, so let's come in here. Let's grab our, we'll keep that for a second. Let's go back to our emitter, or our Dragon Game emitter declaration. Let's change particles per second up to like 1,000. We're still not using emitter edge spread yet. I think we can do that in a second. Let's refresh and see what our shape looks like now. Much better. Super cool. That's what I wanted to do. Excellent, excellent, excellent. Really cool. Loving it. Okay, so now let's get rid of our diagnostic stuff. We don't need that anymore. Let's extract this into a method. We're going to call this show particle generator diagnostics, like that. Comment that out. Refresh one more time, and then we're going to look at just get it for me. Test edge. I'm not seeing it. Let me just hit it. Maybe you're just a little slow, or a little too fast. I mean, all right, yeah, that's way more beautiful. In fact, you can see them kind of side by side here. If you're looking at the stream, you can see our original one on the stream right up there, and our new one way more distributed, right? It feels like it's a rectangle, which is what I wanted to do. I wanted to have that feeling and it would be more evenly distributed. So that's what I wanted to do. Let's do a quick test. We're going to change that to make it tall. I'm totally expecting this to work. We're going to change these around a bit. We're going to make that 100 and this 500, right like that. Let's refresh that. Do another test edge. We'll do a test square too as well. There we go. Yeah, it's beautiful. It's just what I want, right? It totally looks even and distributed all the way around. I love that. Let's get it, make it a square as well. Make it 200 by 200. And refresh. There it is. Yeah, it's really nice. Okay, let's figure out the emitter edge spread. Let's go see if we can introduce that as our last thing that we do, and then we'll be done for the show today. Let's see if we can figure that out. So emitter edge spread is how far away. So we have got this velocity offset. We are multiplying it by, what are we doing here? Particle initial velocity offset length. Velocity offset, where's our, are we getting, or offset is our initial position here. So our offset is how far we initially go in here. I think what we need to do, that is actually calculated here. This is where we need, yeah. So this is my offset. The offset here is basically somewhere in that direction. I think what I have to do is extend the line till it intersects with that point, or get the intersection, get the line intersection with whatever side it's on. This is a little tricky. Right here. Because I want to basically, this offset has got to be, this, what this does here is it says, okay, you can be anywhere inside the rectangle. Find a random spot in the rectangle. But what I think I really need to do is basically say, well, look, if emitter edge spread, is less than 1, then we've got to figure out something different. We need to basically take the angle, look at where it intersects with the line, on that line, and then go backwards whatever the spread is, and then the point's going to be somewhere in that area, I think. Or, ooh, wait. I think there's a more clever way to do this. We can do this. Emitter edge spread is 1. So we can come in here, instead of saying max of this minus that, we can say this dot width. Hold on, let's do this. This dot width minus the emitter edge spread times, can't you just, you can clamp the values, no? Well, I think that's what I'm doing right here, is what I'm doing, is basically I'm saying I am going to, hold on. The random, I want to get, I guess I want to know what you're talking about, well, when you're saying clamp the values. Basically, I want to take these and push them outside. I want to kind of have a kind of a min version on this, whatever the min is here. And it's going to go from half width. No, it's got to go from the edge backwards is what it's got to do. I think what we need to do is this. We need to do this. We need to say, look, we need to create a new number here that's going to be our inner margin, I think. And this is where something can be created. Okay, so our inner margin is here. And that's equal to our, hold on, let me do one other thing. Okay, we're calling get initial velocity, doing this calculation a lot, and I want to calculate smaller point and larger point. here, closest point on line, we do that, get closest point on line. Okay, so I'm going to do this right here. And where we calculate half height and half width, I'm going to create a new function. We're going to call this calculate fields. I think is what I'm going to call this. Like that. And we're going to take this. Okay, so we've calculated half height, half width. We're going to go through all of this. We're going to get larger point, smaller point, and then we're also going to get a line here, I think is what we're going to do as well. We're going to, here we go. So we're going to come in here and we're going to say, look, this is our inner line. Like that. And then we're going to have code that looks like this. And we're going to put that inside our calculate piece right here. Inner line, let's declare that. And good. Okay, so there's our inner line like this. And do I have any problems with, the only problem is I got to make sure we calculate fields at least once. Well, we're going to do that when we set height or width. So these are all going to have values there. So I'm good with that. What else? Smaller point. I wanted to make sure that we didn't have more than one. I think we're good. Okay. So there's that. Blitzkrieg 80B is now following. Thanks for the follow, Blitzkrieg. Okay, so I just wanted to consolidate that. All right, back over in here. Here's where we were, inner margin. So inner margin is going to be equal to, oh, the other thing I want to do is I want to get hold on. One second, we're coming back here to inner margin in a second. Calculate fields. Short and fat. The x distance here. I want to have one other thing. It's going to say this dot smallest distance is equal to that. Then I want to come down here and do it for this. And then I want to come down here and I want to say smallest distance is equal to 0. Okay. I think. You could probably use target value to take advantage of variance. I don't think I want to. I decided against that for this. I wanted very specifically for this variance to be because you can define the shape of the emitter, right? So this emitter is in a rectangle, for example, or a circle, right? And I wanted to not allow creation outside of that. So instead, what I wanted to do is use the number 1 to indicate 100% to the center of it, wherever that is, or 0, which means right along the edge. So that's what I'm trying to do here for this. Smallest distance, I want to smallest distance to, what should we call this right here? Smallest distance inner inside. Here, let's declare it, and then we're going to say smallest distance in. I guess it's kind of a weird name, but we've got that. All right, so we've got there our smallest distance in. Now, whoops, did I delete something? I felt like I deleted something there. Okay, good. Just jumping back through all my markers. There's where I want to be. Okay, so my inner margin is going to be I think that's wrong. Hold on. Smallest distance in for a square is going to be equal to like half height or half width, since they're both equal. That's the smallest distance in for a square. And the others are basically if you go anywhere around and you go in from that, you'll be at the center, right? If I'm at any point on the edge of the rectangle. So if I'm short and fat and I subtract half of the width from half of the height, what happens is I should get, or no, is that not true? The smallest distance in is half height. Sorry, I think I was definitely overthinking that. And here, smallest distance in is half width. That's what I think I want to say. So anywhere around and I'll be to that point. So that's the smallest distance in. So the amount of variance is across the smallest distance in is what's going on there, okay? So now my inner margin is equal to the smallest distance in times my emitter edge spread, I think. And what's going on here? What's emitter edge spread? Oh, it says target value. Wait, did I want emitter edge spread to be a target value? I guess I did. Yeah, that's okay. All right, so then we're going to come in here, and that's going to be get value is the call we need right there. Okay, so there's my inner margin right there. Smallest distance in, right there. So that's that's the range. And then, so now I want to say,
Mark!
yeah, what you got? Line 84 should be half height. Let's see what we got there. Line 84. Yes, thank you. Half width. Yes. That's it right there. Thanks for that. Perfect. Good job. Very good catch, Will.
Bill Bennett rocks.
Because that happens sometimes. All right. Here we go.
Back to the code.
Let's get back to the code. All right. So there's our inner margin, but it's really going to be some random number on this. So if the edge spread is 0 and we have no variance, then the inner margin is going to be totally 0 here. But here's where we can get our random on this. So we're going to say, okay, this is random dot max of this. So this is how far in we can go around the edge. Then the next thing we need to do is then figure out though, so we've got our inner margin, what that is. The next thing we need to do is get a point that is that far back from the edge, somewhere around the edge. And I can't think of a clever way to do this. I can think of an unclever way to do this, but not a really smart, clever way. My unclever way is to basically say, wait. Yeah, it's like I need to subtract is what I need to do. I need the range here. Yeah, I'm not liking any of these solutions. I basically I can create several rectangles to represent these places, have a random choice to choose one of those rectangles based on their area they represent. So it's still evenly distributed because I'm looking for an even distributed area, across this rectangle, across this essentially open rectangle, right? Just to be clear. So let's look at what I'm talking about here. Let's say we're talking about this area in blue here around the edge. How are we going to, let's come in here and make this semi-transparent. Let's give it this kind of amber color for now. All right, so, and let's take this outline color and we'll say no outline. So the idea is this right here. Let me move over, let's bring this over to the other side here. Just duplicate, slide, let's get rid of all of this. Bring this over here. Okay. So what I'm looking at here is, let's make sure we're centered. Okay. So I need to put a particle in this blue area, and I need it randomly, evenly distributed among the whole thing. I need the chances that it's going to be in any of these spaces to be the same as any other space, right? That's what I'm looking for. What I can do, right, once I have this distance here, is I can create essentially 4 rectangles like this. And these 4 rectangles, right, take those rectangles, looks like I duplicated them. These 4 rectangles, then, depending on their area, give them each of them odds that I would, select from them. Notice that these areas are identical to and these 2 areas are identical. So, so that's one of the ways that's my inelegant way of solving this, but it does give me, it gives me that even distribution that I'm looking for. And so that's kind of that's how I think I'm going to approach it. Is what I think I'm going to do. Is I'm going to divide this into 4 rectangles, figure out the area of each rectangle, based on the area, give it that odds that I'll select that rectangle. Then once I've got that rectangle, get a random particle in that rectangle. That's what I think I'm going to do. And I think I'm going to save that for tomorrow is what I'm really going to do. Because I feel like I want to give this a little more thought and get a sense of, hey, is this really the smartest way to do this? Or, because I can't think of it. The other approach to this that I don't like is something like this, where I say, hold on. Whoops, not what I wanted to do. Is that I say, okay, well, that is going to be the area I'm going to find something in. And then I'm going to check, is it in this rectangle? If it is, reject and try again, which I'm absolutely not going to do, right? It's much easier code to do, but it's going to be not performant at all when we're out here, right? Thousands and thousands of times we're likely to find random numbers in here, right? The other thing I could do too is I could do this. This may be a clever solution, where I do an approach where I say, okay, first of all, step 1, here, let's write this out. This is, I think, the clever approach to this. Step 1, find a random X or Y. I think random between entire rect minus inner rect. I would love to be, that's what I'm trying to do, but I can't really minus the 2. But take a look at this, Will. Let's see what you think about this. Find a random X or Y, right? Either one, okay? Step 2, if it's not in range, move it in range. Oh, but we want it still evenly distributed. No. But this is smart, though we can do this here. What if we looked at only the X's or the Y's? If we do that, this is easier to do, okay? So it goes like this. We have, if we are looking only, and so when I say we have 2 approaches to solving this problem. We have an approach that goes down, like this, and we have an approach that goes to the right, like this, okay? If we use an approach that goes down, like this one, it looks like what you're seeing here. I'll show you what I'm thinking about. This is, I think, going to be smarter. All right. If we have an approach that goes to the right, like this, it's going to look different. It's going to look something like this, and a little bit like that. In fact, what we should really do is use just the square from this, since it's a square, and group that, copy that, drag it over. It's going to look like this. One way is to clamp, if X above center, clamp X. Yeah, I don't think I want that. No, I don't want to clamp. I absolutely don't want to clamp, because then I'm going to have clusters of these on the edge points. I want it to do this. So here's the thought process on this, is what's going, well, here's what I'm thinking on this, is that I'm going to say, can I do this? Is this going to give me an even distribution? I'm not sure what to do about the middles. The idea I was thinking of is this. The two ends, we can add them together, find anything in there, and then now those are evenly distributed. The middle pieces, I'm really not sure about. I think the middles I've got to handle in a separate approach. But if I do this right here, I can say, give me any y in this range, right? And then now I just have to find the x, and then these are just, I think I'm going to have to do it area by area is what I'm going to have to do. And I'm going to have to divide them by their overall area. I think there's really no way to do this other than that. So, yeah, I'm not doing that. I'm not going to reject values that fall in the inner rect and choose another random value. Yeah, he's winking. Will's winking. Yeah, there's no way I'm going to do that. Okay, so let's go ahead and let's do the 4 rectangles. And am I saving that for the next time, or am I going to try and push through? I think I'm going to try and push through is what I think I'm going to do. No, I'm going to save it. All right, so we're going to do this. So we're going to do this because I've been going for a while. Create 4x, select 1, weighted by randomly select 1, weighted by area, and pick random spot there. And that's what I'm going to do. That's my to-do for tomorrow's show. Hopefully we'll also find the problem with the SignalR as well. We'll take a look at that. So right now, offset's remaining unchanged. There's no code differences there right now. But that's how we're going to find that, and that's how we're also going to use the emitter edge spread as well, I think. Edge spread, yeah. The recs are going to be based on the spread. 4 recs based on emitter edge spread, random select 1, weighted by area. Nice. That's going to work. So we'll do that. We'll do that tomorrow. Then we'll see that. All working like we're expecting. And with that, let's give away a copy of CodeRushed real quickly. Every day we give away a copy of CodeRushed. That's what I've been using.
CodeRushed giveaway.
We do that because it's awesome, and you're awesome. And we want to say thanks for following us.
Perfectly wicked.
And today's winner is Perfectly Wicked. So excellent, excellent, excellent. Thank you for that, Perfectly Wicked. And congratulations, rather. Thanks, Will Bennett, as usual. Thanks, World Wake, for hanging out there. Everybody else, appreciate you watching, and we will see you next time. All right.